So now we're on the back side of the paper. I crossed off G and H because I really just want to focus on those graphs and the relationship between them. So we're going to talk about the example 2 now, okay? So 2 other walkers start on different paths in the town park. Walker C starts at the 2-mile mark and walks at a rate of 1 meter per second. So walker C, we know that in my equation I have to have y equals mx plus b. My m stands for the slope, or how fast that the walker is walking. So that should be 1. So I have y equals 1x. And then b is the starting point. So this walker starts at the 2-mile mark. Walker D starts at the 5-mile mark and walks at a rate of 1 meter per second. So again, the speed of the walker is 1 meter per second. So I know that I have 1x. And then the starting point for walker D is 5. So I'd have plus 5. So on part B, it says, what does the graph look like? So I'm going to go ahead and graph these things. So on walker C, I know that I'm going to start at 2. So this deals with the meters. And this deals with the number of seconds that the walker has walked. So it starts at 0 seconds. We know that the walker C starts at 2 meters. Then after 1 second, they gain 1 meter. 2 seconds, they gain another meter. And then it increases by 1 meter as the seconds are increasing as well. So this is what my first line would look like. And I know that this is walker C. Walker D starts at 5, so I know that when 0 seconds have happened, we start at the 5 meter mark, and they also increase by 1 meter each second. So we're going to go up 1 and to the right 1, because my slope is always 1 over 1. So up 1 and to the right 1, up 1 and to the right. So I can continue that pattern. And this is walker D. So this is what your second graph should have looked like on the back side of your paper. So part C, it says, what is the point of intersection or solution point? Since these 2 lines are parallel lines, we know that parallel lines never cross. So that means that there is no solution. There's no point at which these 2 walkers are going to meet because they started at different spots and they're walking at the same speed, so they have the same increasing time. Why does this happen? Consider both the equations you wrote and what the walkers are doing. So both walkers started at different spots, so different meter marks. And they're walking at the same speed. So since they're walking at the same speed, that means that they have the same slope. But since they started at different spots, that means that they have different y-intercepts. So if I were to give you 2 equations, like we have up here, and I notice that they both have the same slope, but they have different y-intercepts, I know that automatically, without even graphing them, that they're going to show parallel lines. And since they're parallel lines, if I were to ask you what this solution point is, then we would write no solution. So we have a type of solution that's called no solution because they would never touch. And then from the front side, we know that we would have exactly 1 solution because the lines cross at exactly one point.